All right, this is just a short little video to explain problem 14 in the chapter 6 Mastering Physics homework. It's about conservation of energy, and it involves a big fish and a little fish. Unfortunately, everybody's numbers might be different, so I have to teach you the process for solving it. You may have to solve it with different numbers. Now, in my problem, it tells me that the big fish has 5 times the mass of the little fish. I can do this two ways. I can make up numbers. If the big fish has 5 times the mass of the little fish, maybe the big fish has a mass of 5 kilograms and the little fish has a mass of 1 kilogram. I'm going to call the big fish 1 and the little fish 2, just to help you keep them straight. Or I don't even need to do that. I can just say the big fish has a mass of 5m and the little fish has a mass of m. Either way, the big fish is has 5 times the mass of the little fish. You might prefer the numbers, so let's do it with the numbers. Now, in my first example, it shows that the big fish has a velocity of 3 meters per second and it's swimming to the right. It shows me the little fish has a speed, and it didn't put that negative there. I put the negative there. Let's just take that negative off. It tells me that the little fish has a speed of 6 meters per second, but it's going to the left. That looks messy. And that's important because we need to use conservation of momentum, and momentum is a vector quantity. And conservation of momentum essentially says that our beginning momentum has to equal our final momentum. So I often say it's the momentum before. You say before what? I'll say before lunch. And it has to equal the momentum after lunch. So before the big fish eats the little fish, we have this situation. I have a 5 kilogram fish that's traveling 3 meters per second. That's m times v. That's the momentum of the big fish. And I have a 1 kilogram fish that's traveling negative 6 meters per second. If you're traveling to the left, then your speed is negative. Afterwards, what do I have? Afterwards, I have this. I have a big fish, and inside the big fish, in his tummy, I have a little fish. So afterwards, I have a 6 kilogram fish, and I want to know, how fast is he going? Well, this is 15 minus 6 equals 6 times v. That gives me 9 equal 6v. So I have to divide by 6. This is like algebra 1. And I see that my speed is 1.5 meters per second. Now, I can get that same answer without making up the numbers. But if you like making up the numbers, just make sure that you make your big fish 5 times as heavy as your little fish, unless your problem says that your big fish is 4 times heavy or something. If I use the formula without specific numbers, I can just say the big fish is 5m and it's going 3 meters per second. The little fish is m and it's going negative 6 meters per second. And when I get done, I get a fish that has a weight of 6m and it's going v. Well, what you'll notice is if I work this, that's 15m minus 6m equals 6mv. 9m equals 6m. I can cancel that m out. It doesn't make any difference. I still get that 9 is equal to 6v. And that still gives me v equal 1.5 meters per second. So it doesn't really depend on the actual masses. I just need to know that one is 5 times bigger than the other. So it's really easy to say, well, let them just equal 5 kilograms and 1 kilogram. So that was the first fish combination when I pulled up the problem. Let's look at the next one. So my next one says that the big fish, which I've now decided, this big hungry fish with his big open mouth, weighs 5 kilograms. And he's swimming 2 meters per second. And again, he's swimming this way. Our little fish, which is going to serve as lunch, has a mass of 1 kilogram. And this time, my little fish is swimming 2 meters per second this way. Think before lunch momentum equals after lunch momentum. Before lunch, I have 5 times 2 for the big fish. And I have 1 times -2 for the little fish. If you're going to the left, direction matters with momentum. After lunch, I have that same situation of I have a big fish, and inside the big fish, I have a little fish. So my total mass is now 6. It's 5 kilograms plus 1 kilogram. And it's going some unknown velocity. So that's 10 minus 2. That's 8 equals 6v. And when I divide by 6, let's go ahead and show that step. If I want to know v, I have to divide by 6. And I get 1.3 equals the velocity. This time it's a little slower. Up there it was 1.5. It was a little bit faster. That's because this first fish wasn't going nearly as fast. It didn't have near as much momentum. And then finally, my third case, they told me my big fish, which I decided was 5 kilograms, it was this big, hungry, open mouth, is traveling 2 meters per second. My little fish, which is 1 kilogram, is not traveling at all. It has a speed of 0, so he's just sitting there like bait. So that's going to be 5 times 2 plus 1 times 0. Afterwards, still we got the same situation. Here's the after. I now have a fish that weighs 6 kilograms because the 5 kilogram fish ate a 1 kilogram fish. And it's going some unknown velocity. This is 10 equals 6v. If I divide by 6, I can see that my final velocity in this situation is 1.67. This was actually the fastest. And it was because this fish wasn't going at all. You can see my middle one was my slowest. This was in the middle. So that's how you rank them. I hope this little short video just kind of helps you out, gives you an idea what you need to do. And let's see if we can stop the video.